Now here we have the steps. We want to do step 7. For this step 7, we want to find the multiple linear regression. Multiple linear regression. So, and explanation I will give on this is that explanation. I don't even check the time. Do you have time there? We have 10 step, and we have in 7 now. It remain 3. Okay. So multiple regression. Under that one, we have multiple linear regression means, let me just write the meaning. So linear regression. Multiple linear regression was used more than one predictor. Why I know that linear one is used for only single predictor, but this one is used more than one predictor. So predictor variable, predictor variable. Let me just stop here. So, and also we also want to look at in this case, of multiple linear regression, we will examine how to, let me see, how both the quantity showed how both the quantity showed the quantity showed and discount is yes, right? Have a applied discount applied affect total say. So we want to look at how the quantity showed and discount applied affect the total say. So that means it's two quantity we are going to look at now. So how the two of them affect the total sales. So, and mind you, I told you that dependent variable is total sales while other ones are independent. So we want to look at how they are depending on total sales affect it. So, and also we want to train the models and display the coefficient for interpretation. So that's just what we are going to do under this part. So now let's go there. So here we are going to define the prediction. So let's say define. So for us to define the predictor, predictors, we want to define the predictors and target variable. That's the first question. So target variable for multiple regression. So now let's go down here. Then for us to define the predictors, so now we say x underscore that's multi is equal to df data frame open bracket, no, let's use this, then b open bracket, two bracket like that, then put the quotation mark, right, quantity underscore sold. So now then put comma, and also we want to find the discount to, that is discount underscore applied, so that's the two variable and the two predictors we are going to use for x multi. So now for the y multi is a y multiple. For y multi, so that will also equal to df data frame open bracket, only one bracket, total underscore sales. If it's about to end, let me know. Underscore sales. So now when you are done with this, we are now going to create, create and train the multiple, come create and train multiple linear regression model. So here, for us to create and train linear multiple regression model, so this is how to go about that. You write the model underscore multi, I'm coming, multi. So then you now press equal to and write the linear, so the name of the model, linear regression, then come down, and for the multi you write model underscore multi-linear regression. That will be, we want to fit it to be in form of x underscore multi, comma underscore multi, comma y underscore multi, then close the bracket. So now we have created a train model now. So just like that. Down, after you create a train model, we want to generate prediction, generate the predictions. So want to generate the prediction not visualized here. So how can we do that? So if you want to generate the predictions not visualized here, you say that our y underscore model multi and multi underscore pred. Let me hide this so that you can see my code. Pred, so is equal to model multi dot predict open bracket x underscore multi close bracket. So now let's display it. So display the model coefficient. So if you want to display the model coefficient and interpret Okay. No, it's intercept interpretation. So that would be we want to display then find the intercept. So it's also interpretation. When you find the intercept, it's also the interpretation of the both. So now for us to display that, we print open bracket multi multiply multiple linear regression multiple linear regression coefficient coefficient did I get it coefficient, then you now put the two quotation mark, close your bracket. So now we also want to print the intercept. So print the intercept underscore, then comma, then write the model underscore multi dot intercept underscore, open the bracket, close the bracket. So here, after you did that, then you now come here on another one. We also print the coefficient x, then put the comma, write model underscore multi. My model is not correct. Model underscore multi coefficient, model underscore multi dot coefficient. Just write coef, then press this underscore, then close it. So after you are done all these jargons, then run it. Come. Our code is having error. Okay. Okay. The multi df underscore training discount applied dot. Scikit-Learn linear regressions by multi dot fee multiply is equal to model underscore. Okay. Do you get it on your own side? Hello? It's, it's bringing error. And we don't have much time. We don't have much time. Multi data geo coefficient. Yes, coming home. Oh. Nǹkan tí ń ṣe orí nǹkan tí ń ṣe orí kíní Jupyter notebook yìí. Ṣé because of this multilinear regression that I you are not serious. Okay, now let me just do it again. So this one, multilinear regression. So it's going to be this under this instead of okay multi model and multilinear. So I have to have bracket in front of it. Ó ti wà correct báyìí. Eh? No, no, no. That one is from the so the mistake is that I did not put the two brackets in front of linear regression. So that's just it. So you're supposed to have bracket in front like this. Can you see it now? So someone needs to cross-check this code very well. So here we have the multiple linear regression. Our multiple linear regression coefficient intercept is this. The coefficient is this. So that's it. We have gotten our result. So now for the next one, we want to I want to find ANOVA. If you are tired, sorry. Analysis of variance. So we want to find the analysis of variance of the data set. So for this one, explanation is not going to be much. But let me just explain what we mean by analysis of variance. So it's ANOVA. And ANOVA is analysis of variance. ANOVA test. So whether nǹkan tó máa ń test ni pé ó máa ń test is you always test whether there are statistical wait, can you help me off your speaker? Statistically significant difference significant difference between the mean of multiple group. So that's what we use ANOVA for. So and also on this part now, what we are going to do that here we will test we will test we test whether let me say we test whether the total value we test the total that is total says is derived from derived significantly across different region. So and also we also need to what We are to group. We want to group it group by group. Group the data by region. That means we are going to group it by blocks. Please off your mic. You are muted. And then apply the ANOVA. So that means ANOVA test. So here, these are the things you are going to do under this ANOVA. So, and let's go step by step. Then first one, we want to group. So that we group the data by region. Want to group the data by region and perform the ANOVA test on the total sales. So now, for us to group it, we just write group. After write group, you press equal to, then you open bracket, write df. So we also open bracket again, write df. So that means you are grouping the data frame together. So then you now write region. Write it in capital letter, region. Then put the quotation mark again, close it, is equal to region. Then close the bracket, open a new one. Under that, you write total sales. So after I write total sales, then close the bracket. Then after that, in front of it, you write for region in df data frame. So it's going to be region. So write it in capital letter, put the quotation mark. So it's going to be region. So and dot unique bracket twice, then close it, normal. So then after you did that, you're now going to find the f statistics. F start underscore f start. Use f start because ANOVA is based on the f statistics. That's the f value, statistical value of your calculation. Then you're also going to find the p value. That p value can be found in the table, statistical table. But you don't have the statistical table, but I will show you a website you can use to get that p value maybe later in future. So now we have p value also, and also the p value, and then we have stats dot f underscore, let's say one way ANOVA. Let's find the one way. So we have one way open bracket, then we say group, then close the bracket. So now let's display it. Say display the ANOVA. I don't get ANOVA test result. So for us to display that one now, we say print open bracket, write quotation mark ANOVA. So you write it in capital letter, then write result, then put this. So close the bracket. So also, let me change this to capital letter. So now also come down. After you come down, then the next thing I'm going to also say is also want to print the f statistics. that one can be found after your calculation. It depends on the test you use. Maybe you use statistical test, or you use any test you use for the analysis. So you will find F statistics. Then after you find the F statistics, you are going to find the P value. So put your underscore, write F underscore start. So then for the next one, we also have, are you there? Mr. Peace. Okay. So we also have P value. But wait, oh, Google Meet, your Google Meet is very long. Oh. So we also have P value, P underscore value, P underscore value. Then you close the bracket. So that's all. Now let's run the code. You see, we have get our ANOVA result. Our ANOVA result for F statistic is 0.97 kinecon. So our P value is 0. This. So now with this result, when our calculated value, which is F statistics, is greater than P value, which is table value, then we fail, no, we reject the null hypothesis. But if the P value is greater than F statistics, we accept, we fail to reject the null hypothesis. That means the column koruke, what do you call the name of this the total stage and the region, they have a significant difference between two of them. So we have two, they have the significant difference between two of both the regions and the total stage. Do you understand now? So our F statistic is greater than the P value, so we fail to reject, we reject the null hypothesis. Reject the null hypothesis. So now you may not understand that one because you are not a statistical student. So step 9. Do you understand this? Step 9, please. Are you there? Time series. Step 9 is time series analysis. Yeah. Meeting has ended. Okay. So time series analysis. So do you get the same result for the same analysis? Time series analysis. Let me just do a brief explanation on that too. So on this one, we say time series analysis allows you to, let me say, don't let me use you, allows us to observe, it allows us to observe trends. I don't know, maybe you know what we mean by trends. It allows us to observe trend over time. That's time series, as simple as that. So and also we also have let me put the, what we are going to do. We first need to, we first convert the data, we first convert the date, our date, because it's dealing with the time. So we have to focus on date, anything related to time, date, year, and so on and so forth. That's the time series based on. So date line, date time, focus on date time format, and set the, and set it as, I set it as the index, as index. So now we also have to, let's say then coming. So then we also need to watch, re-example we example the data by month. Example the data by month. To compare let's say no, we have to compute name. So to compute monthly total sales. Compute monthly total sales. And now we are now going to plot the trends line. Trend line over time. So now that's all. So for us to do this now, let me continue it. So for us to do this, so write first convert date to date line. To date time format and set it as index. So now then also for us to convert the date to date time format and set it as index, so write df open bracket date, write date, so then close the bracket, then you now write equal to pd, that data frame dot to underscore date time, so date time open bracket df open bracket, then write quotation, then write date. So now here you put the quotation mark again, close bracket, let's go down. So I'm coming, so go back this part. So also write df, our df dot set underscore index. Don't forget that's our question. We based on index, we want to set it as index in the index format. So now we set it as index, set underscore index open bracket date comma in place is equal to true, and close the bracket. So now the next step is that we want to resemble. So the example that we resample data to a monthly frequency and then now sum it, and then sum total sales, that's called sales, sum total sales. So for us to do this, you just write the monthly underscore sales. Let me use small letter. The sales is equal to df dot resample open bracket capital M, but before you write M just put the quotation mark here. So then close the bracket dot agg. So here we are going to put the total sales. You write total sales, total underscore sales, then put the quotation mark. After I put the quotation mark, then here we write SUM, that's sum. So we want to sum everything together so that we can be able to get the total distance for it. So here now let's plot. That's the third question. Say that plot the trend lines time series. There's a time series of the total sales. Total sales. So that's the last one we're going to do now. So we'll just write plt dot figure figure open bracket fig size. Our fig size is equal to, let's use 10 by 6 this time around. So let's close this twice. Then after that, write monthly. So monthly underscore sales dot plot. So now we also write plt dot title. Once you look at the title of your dataset, plt dot title open bracket quotation mark. That be our title is going to be total sales over time. So close the bracket. So now our the next one is also want to put the x label. So our x label is going to be date. Don't forget I told you that the time series deal with the time, date, years, and so on and so forth. So our x label is going to be date and y label is going to be total sales. You understand? So now we have it to be labels, y labels open bracket total sales. So and now let's plot plt dot show open bracket. So now let me run plt again. Date, that's it. Dot sum. We have date pd2 date time is def dot set underscore index. The monthly def dot example. What's now happen to my code? It's correct now. So on under the date here, but this date is correct now. But the time, that says one two is correct. One shell. Okay, this one is date. Okay, no, it's correct too. It's correct. Ah, I don't even know. So for the date, Abi, let me check it. Okay. Brought the name of the column. Key date. The type of the error. Show key error key. Okay, okay, okay. The date. Yeah. So ṣó fẹ́ kí n lo small letter fún date eléyìí? It's not going to be proper. Not going to be proper like that. You don't have much time again. Oh my God. I always I always hate this stuff like when the column there's clinical. So the date. I know is that gbogbo eléyìí tẹ́lẹ̀ tí ẹ kọ síbí gan ó ti pọ̀ ju tèmi lọ. So let me paste it. I think it should work now. It not work. So it's not working still. Keep bringing error. DF. Show me my train. It's DF. This is the date here. Sharp. Okay. The pi check the time training. The date here. Oh, do you have any face? You don't have any space now. So I don't think there is space there. You don't have any space there. Hmm? You don't have any space. It's together. Together. Is there any space there? No. This one too doesn't have any space. This one too. Okay. P. Okay. Let's correct it for us so that we're able to know exactly the problem. So let me run this. It's still bringing error. Okay. So I don't really understand this one. Import the Matplotlib and employ the Seaborn. So expected loss. The one that this ChatGPT correct concept is the error. So I'll work on it. I'll work on it. Then I will let you. Maybe we'll start from there next class. So no worry. Start from there next class. Yeah.